In an actual kitchen experiment, 1 quart of cooked spaghetti was measured out level with cold water so that the spaghetti strands just break the water surface. 9 ounces of water were drained. Assuming the spaghetti strands were polymer chains, what is the ratio of the specific volumes of the perfectly packed state to the actual disordered state? Assume a hexagonal close packed array. Hint: allow for water between perfectly aligned spaghetti strands. Calculate the average angle between strands, theta by 2, given by the ratio of the specific volumes. Specific volume is the reciprocal of the density. Interpret theta by 2 in terms of intermolecular orientation and the randomness of the amorphous state. For part A, assume that this is the container and this is the spaghetti strands, and then they're adding water such that it just covers up all the strands. So the water will occupy the spaces in between the strands, which means total volume is equal to volume of spaghetti, of the cooked spaghetti, plus volume of the water drained. So the total volume is 1 quart, and 1 quart is 32 ounces. So the total volume 32 equals volume of the cooked spaghetti plus the water drained, which is 9 ounces. So volume of spaghetti is 23 ounces. Packing fraction for this cooked spaghetti is volume of spaghetti, which is 23 ounces over 32 ounces, which is 0.72 or 72%. In a hexagonal closed packing, the atoms are arranged in the corners of a hexagon in a lattice structure, and there is one atom in the middle of the hexagon, and then in between these two layers of hexagon there are 3 atoms which fill in the void. These 3 atoms fill in the void that is created when we pack these atoms in an hexagon. So we have to assume that these are packed like this, touching each other. So if this distance is a, and if the radius of the atom is r, then a is equal to 2r. So the next layer will have atoms here in these voids, and then again the layer above will have atoms like this, which are right above the lower hexagonal layer, and so on and so forth. This layer is similar to the one here, and this is the middle one, and the one in green is the lower one. So and so on and so forth in 3 dimensions it extends, and that's the lattice structure. Now each atom in the corner of the hexagon is shared by 6 other unit cells. So the contribution of each atom to a unit cell is 1 by 6, and there are 6 of them. in one hexagon, and there are two hexagons, so that times 2. Plus, if you look at the atoms in the center of the hexagon, they will be shared by two unit cells, right? One which is depicted here and the one that is above it. So, and there are two of them, so it's 2 times 1 times half plus the ones that are filling the void and that are in between the two hexagons. They are present only in this lattice cell. They are totally inside. So each atom is totally inside the lattice cell. So it's 3 times 1. So this gives us 2 plus 1 plus 3. So there are 6 atoms per unit cell. The volume occupied by these 6 atoms would be 6 times 4 by 3 pi r cube, assuming they are spheres and r is the radius. Volume of this hexagonal unit cell would be 6 root 3 by 4 times 4r squared times c, where c is this distance. It can be shown that c equals 2 root 2 times 2r over root 3. So if we divide the volume occupied by the atoms over the volume of the unit cell, we get a ratio of 0.74. So the ratio of specific volumes of the perfectly packed state to the actual disordered state is 0.74 is to 0.72, which is 1.03. So substituting Vc over Va, the ratio of the specific volumes in this equation, plugging in theta equals 180, then theta by 2 is 90 degrees, and plugging in various values of theta, like theta is equal to 90, then theta by 2 is equal to 45. Theta is equal to 0 is not possible because sine theta by 2 in the denominator cannot be 0. Trying various values, the closest value is when theta is equal to 180 degrees, making theta by 2 is equal to 90 degrees, which gives the closest value to 1.03. So the average angle between the strands is 90 degrees, which means that there are strands equally distributed between 0 degrees and 180 degrees. So it is completely random. So it's totally amorphous.